amp configurations is the inverting amplifier configuration, as you see here on the right hand side of your screen. In this configuration you have a voltage source denoted here as VI, the input voltage. You have two resistors, one here we're labeling R1, the other labeled RF. This is our feedback resistor. And you have grounded the input to the non-inverting input of the amplifier. Notice that because we do have negative feedback, that is, we have a feedback pathway from the output voltage back into the inverting input, that means that V1 does equal V2. That is, the voltage at the inverting terminal is the same as the voltage at the non-inverting terminal. Also, because we are assuming this to be an ideal amplifier, there is no current flowing into either the inverting input or the non-inverting input of the amplifier. We're assuming this amplifier has infinite input resistance, and thus no current can flow through. Now, if we analyze at this V1 node using Kirchhoff's current law, we know that the current flowing through R1, this current I1, must come into this node, and since none of the current is flowing in here, all of that must go through the feedback resistor. And so what that tells us is that I1 equals I2. None of I1 can branch off and go here. The only place for it to go is out there. You can effectively think of this as an open circuit. And so if we put this mathematically, I1 equals I2, and using our same nodal analysis technique, this means VI minus V1 over R1 equals V1 minus V0 over RF. So here we see VI minus V1 over R1, V1 minus V0 over RF. And so those currents are equivalent. And since we know that the non-inverting terminal is grounded and we have negative feedback, that means that V1 is 0 volts. And so if we plug in 0 for V1 in both of these cases, we have VI over R1 equals negative V0 over RF. And so here we're going to multiply both sides by RF and move the negative over. And what that gives us is that the output voltage is equal to negative RF over R1 times VI. And so because of this, we're going to see that we have a negative gain. That is, that we have an inversion of the sign of the input signal. So if we had a positive voltage on the input, we're going to see a negative voltage on the output, because real resistors can only be positive values. And so the polarity is going to be reversed. And so if we wanted to draw this as an equivalent circuit, we could write this as a dependent voltage source, where the voltage here and the voltage for the output is going to be equal to negative, notice that this is upside down, RF over R1 times VI. And VI is the input voltage, and you can notice that we have a finite input resistance here.